Right. So I work for the Financial Times on their mobile application, which is offline first, single-page app, responsive and everything. This year, we've finished a major upgrade to the code base and migrated the app to promises. So today I would like to share the experience we've gained in the process and show you not only how to use promises, but paint a bigger picture when and what for you would use them. First warning, I'm going to use the ECMAScript 6015, whatever they call it now, including arrow functions. So if you see a fat arrow, just think of it as a function. And I'm going to show you a lot of patterns that are available in other async libraries. But I'm focusing on promises because they're now part of the language. So it's not a library anymore. It's vanilla JavaScript. But I must admit, when I first heard about promises, I didn't get it. I know callbacks, they work. So I thought, why should I learn this new thing to just type more? It's like, it's still a callback, but now I have to type .then. Oh, but somebody told me it decreases indentation. And now I know it's absolutely not the point of promises. They're not the library for formatting your code. So I'm going to kill this myth right away. First question, when you write such promise chain, this is a promise chain. It runs first, second, third function. They're all async and run one after another. And when you write such a flat promise chain, the first question that comes up is, how do I access a previous result from the chain? And the answer is, use closures. It will increase indentation, but it just works. So promises are not to flatten your code. They're very important standard for DOM and libraries to talk to each other about asynchronous things and reporting errors. And it also makes it much simpler and easier to write reliable asynchronous code. And how nice it can be, I'm going to start with a simple result for simple caching of functions. If it was synchronous, it's not too hard. Let's say we have a compute answer function, and it's slow, so we want to wrap it in something that will cache the result. We create a cache object. If the answer is not in the cache, we compute it, put it in the cache, but other than that, we keep reading it from the cache. For synchronous function, that's super easy, 3-4 lines of code. But if we want to make it async with callbacks, now we have to add a callback to our function, and to function that calls it, and to probably half of the application. So that's the first annoying thing. And this code might still not look too bad, because it's buggy. It has a terrible bug that can bring down the whole server, and it's called the thundering herd problem. If we're trying to cache something, and it's asynchronous, first time we call the function, it will see the cache is empty, so it will start running the asynchronous process in the background. If we call it the second time, very quickly, we'll still not have any result in the cache, so the cache will still be empty, and our naive logic in that function will launch another process again. And the third will come and launch, and launch, and launch, and it will make server or the application slower and slower and slower. And if everything doesn't die at this point, you might be lucky and one of them will eventually finish and then put result in the cache, and only then a cache starts working. So to fix this with callbacks, I need to have a queue of the callbacks waiting during that intermediate state where it's not cached yet, but it will start caching. So I need arrays of callbacks. Oh, and that's still buggy, because I need to handle exceptions, recursive calls, pass errors, and so on. So at this point, we went from 4 lines for synchronous code to this whole ugly function, and it's still probably buggy. So I don't want to write this ever again. I should have a library for this, and it turns out promises are actually a great library for that. So let's go back to the simple version. that worked with synchronous code, what do I need to change in that function for it to work with asynchronous promises? Nothing. And that's the power of promises. They bring back the standard behavior of JavaScript where functions return their results, except instead of actual result, they return a placeholder object, a promise. But you can put this promise in a cache, for example. You can assign it to a variable. You can pass it to another function, just as if you did it with a regular synchronous function. And this works much better than the long code based on callbacks, and that's all you have to write if you use promises. So if callbacks are not your problem anymore, let's look at another pattern, which is serial queue. If I have one thing to call after another, and all these things are in the same function, I can use just regular promises, .then. But if those calls are in different places in the code base, they might be in some click callback, they might be in a timer, or just separate modules. I want to hook them up dynamically. So if I call this function 10 times, it will run 10 things, but only one at a time. That's useful for things like displaying error messages to the user. You don't want to display all of them. You want to wait for a user to dismiss one before you show another. Or, for example, running animations. You don't want all animations to be jumbled. You want things to move there, and then there, and then there. So that kind of a queue is useful for this. Let's see how we can implement it. I'm going to start with a function that takes function for the next thing to run as an argument. And I'm going to assume I have already tail of the queue, which is a promise. It's a variable that holds promise for the previous thing that's already running or has run in the past. I can attach .then callback to it. It doesn't matter whether a previous one has finished already or it's still running. Then we'll always wait for it as appropriate. And the result of previous thing, then next thing, is going to be the end of my queue. I don't need any array to store all the tasks that are queued. I'm going to rely on promises to handle this queuing for me, so I only need to keep track of the last element in the queue. At this point, this works for queuing tasks, but needs one more thing. There's a bug. You see, promises are modeled after regular synchronous JavaScript execution. And when JavaScript throws an error, rest of the function is aborted. It skips over rest of the code until a catch block. The same thing happens with a promise chain, that if an error happens, all the .then functions will be skipped until you add a catch. But because in our serial queue, we want to pretend that every task is completely independent, we want to catch those errors before running any step. This will stop errors from propagating and ruining all of the chain. But we're still passing the previous element to the caller, so we're not entirely ignoring errors. We're just making it somebody else's problem. And with promises, that's generally a good idea to make errors responsibility of the caller, so you pass it up and up and up the stack to the place where it's easier to call. And I've started with the assumption that we already have a promise for the beginning of the chain. But what about the very, very, very first call of this function where we haven't got anything yet? Instead of adding some sort of if-else to the function, I'm just going to create an empty promise. Using promise.resolve, it converts anything you give it to a promise. If you don't give it anything, it will just create an empty promise that immediately resolves. It's immediately usable. So it's super handy for any case where you want to attach .then to something, but you don't have it yet. Or if you have a fragment of code that you want to convert to promises, but you don't know whether the code will return right values or whether it will throw unexpectedly. So wrapping it in the promise resolve .then and then a callback function makes it nice and safe. So this is a function that if you call it 10 times, it will run 10 tasks, but ensure only one task runs at a time. There's a similar case, but where when you call it 10 times, you want it to run only one task at a time and keep reusing it. This is useful where you're downloading stuff from the server, refreshing some sort of data, and the function could be called from anywhere, from a button in the UI or just any function in your code. If there's already a request to the server running, it's faster to wait for that request to finish and reuse that result instead of launching more requests for the same thing. So we can wrap it in a nice function, so we don't have to think about it explicitly. So let's say we have a function that queries some JavaScript API to get current weather. The first one will start a request, but if we call it next time and next time, these will just reuse the previous result until sometime later when we think we need to check fresh again for the next request. So how do we implement that? Let's say we have a fetch function that returns a promise for JSON from some API. So we're just going to store that promise, that result, in a variable. And in our logic, if we don't have the cached result yet, we'll start a new request. Otherwise, we'll just keep returning the same again. And we don't have to worry about registering callbacks here. Promises will do it for us. So there can be multiple listeners, multiple pieces of code waiting for a result of that promise, but we can just keep returning the same thing. But we don't want this one result to be returned forever. We want to let next one run after this one finishes. Or I could wrap it in a set timeout and cache it for, say, 5 seconds. But eventually, I want to clear it so the next one can start. And here's a problem. Let me focus on the red bit here. After a promise, if .then is called only on success, but we want to clear our cache variable on success and on the error. Otherwise, we would be stuck with an error forever. So I need to attach .then and .catch, both doing the same work of clearing the promise. I don't like that, because I cannot even reuse the same callback function for this, because in case of success, if I want to pass the results through without modifying it, I have to use return. But in case of error, if I want to pass the error through without handling it, I have to throw it again. Because in promise land, if the catch handler returns normally from the function, it means the error has been handled. So it's not an error anymore, and it's sort of a successful result. So the catch handler that just needs to do some work and propagate the error further has to do throw. So the code duplication combined with that gotcha annoys me so much that I wrote a helper function, which is .finally. It's in non-standard promise libraries, but it haven't made it to the official standard, unfortunately. So you have to modify promise prototype and hope it doesn't break. So don't do it if you're writing a library, but if you're writing a project that is under your control, I recommend checking out npm module that does this one thing. And finally, we'll propagate the result further for you and only call your callback function after promise finishes with error or success. And it's super handy for all kinds of cleanup functions. Say, if you're showing please wait window while a process is running, you want to hide that window regardless of whether that was success or failure. And that's what finally is useful. So the next pattern is going to be about events. Events in JavaScript are generally fine. They work great without any help of promises, except one thing, which is one-time events, like load event, DOM ready, all kinds of init or open events in your custom code. The problem is, if you don't attach your event listener early enough, you'll miss the event, And your code will be just sitting there waiting for an event that already happened and will never happen again. So in case, for example, DOM ready, you cannot just attach this like that in an asynchronously loaded script. You actually need to check whether the event has fired in the past and then synchronously do whatever startup you wanted to do, or wrap it in a function and have it wait for the event. This is pretty problematic because you have to duplicate code, you have to remember about this pattern, and if you're using a lot of events, you repeat yourself a lot. And it has been solved pretty well in jQuery. jQuery, instead of making it event, has a function like call me when you're ready, whenever you're ready. And it's always called. If you attach it too late, it will still call it. So it's pretty bulletproof in that way. And the good news is every promise callback works the same way as well. If you have a promise object, you can attach .then to it, and it will always call your callback. If the result is already there, it will run your callback immediately. That's nothing special in terms of promises. It's just a convention, but it's very, very convenient to use it this way. So, for example, Service Worker already uses it. There will be more DOM APIs in the future that work this way. But it's also very useful for your own applications for handling any sort of custom initialization code. So you can take a startup of your application, of your library, of your plugin, whatever, wrap it in a promise, and put it in some kind of a .then variable. For example, have you ever used Facebook JavaScript SDK? On client side, it's super annoying because it loads asynchronously, it initializes asynchronously, and until the startup is finished, if you try to use it, if user presses share button, you will just get an error. But if you have a hypothetical function like load script that returns a promise, and then you run init function after that, you can assign it to some .ready variable, and then every time you use this API, do ready then, and you can use it, regardless of whether it has loaded already or hasn't loaded yet. It will just safely and reliably work always. Now, this may seem trivial, but in our app, it actually helped to improve performance a lot. We used to have this huge startup sequence. Because we're offline first, we have to rely on a database, so we had to wait for it to open. We had to load some third-party libraries. We had to wait for CSS to download. We had to configure some plugins, and so on and so on. So our application wouldn't do anything until everything has finished loading and starting. So we broke down into smaller pieces, and every piece was this thing .ready. So now, different parts of the application can start as soon as they can. And we don't have a bugs that we've started something too quickly before, say, database is ready. We just wrap all our code in db.ready, and it always works. Now, I've been talking a lot about running one thing at a time, which may seem strange when I'm talking about promises, which are for handling code in parallel and for concurrency. This is because running in parallel is the default for promises, so it just works. There's nothing to talk about because it automatically does the job. But just for sake of completeness, I'm going to mention, with synchronous code, if you want to process an array, you have one array of one thing, apply a function, you get array of a new thing, you use .map. The same thing works with promises. Let's say instead of just uppercasing, we're going to use the new cool startup to uppercase.io and use the RESTful API to uppercase our strings. So we'll end up, if we map strings to the API request, we're going to end up with an array of promises. Working with array of promises is much more convenient than having a promise for an array, by the way. However, we still eventually want to get to actual results. And to do that, we use promise.all. It will wait for all the promises. That's important to understand that promise.all doesn't run them. Promises run as soon as you create them. So map function has run all the requests in parallel, and promise.all just waits for the request that we're already running. One more gotcha is promise.all will abort everything on the first error it sees. So if you're making, say, a bunch of requests to a server, and you want to keep whatever succeeded and ignore some parts that failed, you have to add a catch handler to every single item and turn the error into some other placeholder value pretending to be success. Right, so that's running in parallel, everything at the same time. And it turns out the dot reduce is a nice counterpart for it, that it runs one thing at a time. The code inside it looks exactly as the serial queue I've shown you previously, but now we're running the whole thing as a single expression in a single place. So we attach .then function after a previous element. We have to remember to catch the errors, so one error doesn't break the whole chain, assuming we just want to run as much as we can instead of failing on the first one. And we have to start the chain with something. So again, we're going to start with an empty promise. This pattern, if you haven't seen it before, might look a bit confusing and intimidating. So that's why I'm showing you, because it's a nice self-contained expression that comes handy. OK, so I've already shown you a lot of code. So to wrap it up, I'd like to talk a little bit about the future of promises and its integration with the language. JavaScript has this interesting thing in duality between its syntax and global objects that represent that. So when you're using a string with quotes, you're actually using the global string object. Or if you're using Boolean expressions, behind the scenes, you're using Boolean objects. Interesting thing is, in the first version of JavaScript, there was no syntax for creating an array. There was no JSON. So you'd create array with new array constructor and put things into array one by one. Only later version of JavaScript got the syntax that we all know. There are more complex relationships between the standard objects. For example, errors and try-catch go into territory of flow control. And now there's the new promise thing, joining the family of standard built-in global JavaScript objects. And like the other objects, it will also get a native syntax. So you will be using promises without explicitly using them, without .then, just with a transparent syntax like this. This already works in Microsoft Edge, and you can compile it for browsers with less advanced JavaScript support. And the way it works, the functions that return promises must be annotated with async keyword. But after you do that, you can pretend that your asynchronous code inside is synchronous. For every async function, you can wait by blocking with a wait keyword. It doesn't block the whole JavaScript main thread. It only blocks the current function, the current async function. So it's still good, asynchronous and not interfering with the user interface, but you can write the code normal way, without any callbacks, without any jungle of .then calls. And it makes asynchronous promise errors reported as regular exceptions that can be caught with try-catch. So for the first time in JavaScript, you can use try-catch around asynchronous code, and it works properly. So I think that's a great feature for promises, and they're already very useful. The patterns for the queues, parallel processing are very convenient in applications. And if you migrate the whole code base and libraries to promises, you don't have to deal with mixed of callbacks and promises, and eventually you'll be able to migrate to this nice syntax. So thank you very much for listening. I know there's been a lot of code, and you probably didn't have time to make notes, so slides with the code are available at that URL, and you can ask me questions on Twitter if we run out of time, but I think we have the time for 1 or 2 questions now. Thank you.
Hi, great presentation, thanks so much. I'm over here, hi.
Okay, I don't see you,
okay,
but anyway.
I'm still here. In the example that you showed, where you add the catch callback to the serial queue function, you added a no-op function. Was that just for the sake of the example, or is that?
I've deliberately added no-op function. In that particular case, it didn't matter what I add. The point is, I have to pass it a function, and I have to catch the error. Whatever that catch function would return would become a result of the promise passed as an argument to the next function.
Right.
But our next function was defined not to care about this,
right.
So that was fine.
So the pattern would be to just pass those errors as resolution values to the consumer code.
So empty function is a function that sort of returns undefined. So it turns error into success value that is the undefined value.
Okay, cool. Thanks.
I think I have 2 questions. The first one, callbacks for promises can also return another promise to be resolved later on. Have you been using that in your application?
I assume every callback may return either regular value or promise. You don't have to worry about it, because if you return a promise, promises will automatically wait for it. So promises are automatically detected if they're used as return values or input values for promise.resolve, and they sort of extend your promise.
Yes, but have you been using that in your, in your application? Because I understood that you divided up many different initial processes to many different objects with their own ready part, and you were just hooking up to that ready part.
No, for example, for serial queue, it's important that you create the promise at the point when the callback is called. You cannot create them all ahead of time, because they would start running ahead of time.
Okay, so the second question is, sometimes you used catch part before next then, and sometimes you used after the previous then. I understand that catch returns another promise or not?
Catch also returns another promise,
so
yes.
You're changing the order of that code.
Right, if you put catch before you run .then, it will guarantee that your .then runs. If you put it after your .then, whether it runs or not depends on what happened previously, but after it, it will eat the error and ignore it. So it depends on what you want to achieve. In some of the patterns here, it doesn't actually matter. Okay, thank you very much. Now it's time for Rachel.
Thanks, Kornel.